영상이 시작되기 전에 먼저 등장할 5개의 문장을 보여드릴게요. 빈칸에 들어갈 표현을 유추해보세요. 단어 하나하나를 직역하지 않고 전체 의미에 맞게 의역하고자 노력합니다. 그게 바로 영어식 사고의 출발이에요. 그럼 시작해볼까요?
This layer is the bedrock. It decides how scalable these robots can actually be. More powerful embedded processors. You fuse data from cameras, radar, tactile sensors. Robots working alongside people.
Welcome to Magic of Listening. We've had lots of requests for us to break down the world of robotics. It's expanding so fast. But instead of just looking at the finished robots, we thought, let's go deeper. Straight to the core components. This is the first session in a little series we're doing, really trying to understand the foundations, the tech that's actually driving this revolution.
Exactly. And we're starting with what some people call the component layer. It might not sound glamorous, but honestly, it's everything. This layer is the bedrock. It decides how reliable, how scalable these robots can actually be. We're talking semiconductors, sensors, actuators, power, materials, the basic building blocks. If these aren't right, nothing else works.
Okay, right. Let's unpack that. So how do robots think? It starts with the chips, I guess.
It does. You've got sort of two main types. There are the simpler ones, the microcontroller units, MCUs, low power for basic tasks. But then you need more powerful embedded processors for the really complex stuff, the real-time actions.
And handling all the data coming in, that's getting tougher.
Oh, absolutely. The big trend, the really critical thing right now is edge computing. Robots can't always wait to send data to the cloud and back. They need to process things like sensor data, avoiding obstacles, recognizing objects right there on the machine instantly.
Okay, so that means serious processing power needed locally.
Serious power, yeah.
Yeah.
That's why companies like NVIDIA are so important. Their GPUs, first made for gaming, then AI, are now key for robot vision. And you got Intel, of course, with CPUs and their own edge AI stuff. But what's interesting is you also have specialists like NXP. They're huge in MCUs for industrial robots, focusing hard on safety and reliability.
Right.
That's crucial in factories. It's less about raw speed, more about guaranteed, safe operation.
Makes sense. Safety first in those settings. Okay, so if chips are the brain, sensors must be the eyes and ears feeding that brain information.
That's a good way to put it. You have the standard stuff, like cameras, very important, but also LiDAR that uses laser pulses, right, to map out surroundings in 3D. It's like giving the robot a whole different way to see. Mm-hmm. And force torque sensors. These let the robot actually feel pressure, like when it's gripping something delicate. Gives it that sense of touch.
So we're moving beyond just vision then, combining inputs.
Exactly. That's the idea of multimodal sensing. You've fused data from cameras, maybe radar, tactile sensors, to get a much richer, more reliable picture of the world. Keyence and SAE are big names in the industrial sensor space, known for reliability. And for LiDAR, you have to mention Velodyne. They merged with Ouster. Now they really were pioneers in that 3D mapping tech for robots.
Okay, brain senses.
Right.
Now for the muscles, the parts that make the robot move.
Right, the actuators. These are essentially electric motors, but often paired with very precise gearboxes or reducers. Especially in robot arms, these high-precision reducers are absolutely critical. They give you the smooth motion and the force you need for tasks.
Ah, so any tiny error there gets magnified way out at the end of the arm. Precision is key.
Totally. Harmonic Drive and Naptesco are the giants in that specific area, the high-precision reducers. And the big challenge for them, and for everyone really, is this balancing act, making components super strong, but also lightweight.
Strong but light. Why light?
For safety, especially with robots working alongside people. A big, heavy robot arm bumping into someone, that's dangerous. But a lighter arm, maybe with some compliance built in, they can share a space much more safely. So yeah, safety design really starts right down in the actuators and gearboxes.
Got it. Okay, nearly there. Last couple of pieces. Power and structure. Batteries. Still a limitation for mobile robots.
Still a major one, yeah. Especially for robots that need to operate for a long time or carry heavy loads. Energy density is the challenge. What's kind of interesting is the connection to electric vehicles. The huge scale of the EV market is actually helping bring down battery costs for robotics. So you see big EV battery players like CATL and LG Energy Solution becoming really important suppliers for robots too. It helps make mobile robots more economically viable.
That's a neat crossover. So what's next for power?
Well, the hope is for things like solid-state batteries, more energy, safer, and better wireless charging is definitely needed. And the materials, the structure. There's some really cool experimental stuff happening. Think smart materials,
Smart materials, like what?
like polymers that can sort of heal themselves if they get scratched, or alloys that remember their shape. Imagine robots that could repair minor damage or even change form slightly. It's still early days, but very exciting.
Wow. Okay, so pulling this all together, it really sounds like this component layer, while maybe not the flashy part, is where the real innovation and competition happens.
It absolutely is. Every little improvement down here, slightly better battery, a faster chip, a lighter gear, it doesn't just add up. It multiplies the robot's overall potential. That's how you get scalability and new capabilities.
It really sets the foundation for everything else. You know, thinking ahead, it feels like the next decade could see a lot of technology crossing over from industries like aerospace and automotive into robotics. So here's something for you to think about until our next session. Which one of these components, the chip, the sensor, the actuator, the battery, which one do you think will have the biggest breakthrough first, the one that really changes the game? Let us know what you think.
영어와 시사경제 두 마리 토끼를 한 번에 잡는 알찬 시간 되셨다면 구독과 좋아요를 꾹 눌러주세요. 감사합니다.